The erosion of a waterfall creates a rounded cut in a cliff edge. This is what scientists call a cataract. And at the base of the cataract can commonly be plunge pools. Now another feature we have to understand are sediment lobes pushed by a water current. This is an important feature to be able to identify. Now we're in the Hangdong Mountains of China. Could this be a plunge pool, and could this be a rounded shape of a cataract? Well, let's keep going downstream to see what else we can find. Here we can see sediment lobes are pushed upwards and even uphill. We can see that these formations are full of sediment lobes, all indicating an uphill current direction. And they're right next to ripple formations that have a wavelength of 4,000 feet. These are very directional features. And they're full of these V-shaped formations. How did these V-shaped formations form? Well, they started off as ripples, and then they got separated and sculpted by water current. These are what I call streamlined ripples, and they can be found on riverbeds and observed to move downstream. And when we go to our mystery spot in Mongolia, which has sediment streamlined around this mountain here in an uphill direction, now that we understand the plunge pool and the rounded shape of a cataract, we can see the whole picture of this erosion. And on these sand deposits, we also find massive ripples as well, with a wavelength over 3,000 feet. And next to it is the same features. Okay, I got a rebuttal from my last video that says that this is actually a feature made by ice and that this is a feature made by the wind, and that my interpretation of this showing a continuous water current is actually incorrect. Now I'm going to refute that argument by showing you a feature that only water can make: river terraces. Okay, so this is the feature on a topographical map, and this is that river that cuts in between, right by the sediment lobe. Let's zoom in on it and see what we find. We find that this river has a bunch of terraces. Each of these terraces indicate the width of a river, and it shows the sequence of its recession. And now we can see that this river was once over 20 miles wide. And when we go to the east of this feature, we find that there are also a lot of river terraces and scours in this area, even features of cataracts. And this cataract feature is right next to river terraces that indicate a river width of 2 miles wide. This was a swift current that made a streamlined intermediary. And this feature here is a scour made similar to a plunge pool. These erosional features are too detailed to be made by ice and too catastrophic to be made by the wind. Now, if you're going to stick strictly to the ice paradigm, where glaciers carved all of this area, how are you going to explain this feature here? Because in order for ice to have made this feature, it would have had to increase its erosional force in a specific area and then lift up afterwards so that a valley is not created. This is focused erosion and is not something ice sheets or glaciers can do well. But with fluid dynamics, moving water has an undulating force and a coalescing force. It is these two features of fluid dynamics that is responsible for the scars you would find in a scabland area. The scours we find in the Washington scablands are the exact same feature that we find in China. And both of these scours are correlated with having salt deposits. Thanks for watching, and as always, please subscribe and like. And if you have any questions, please leave something in the comments. I'd love to have a conversation with you discussing the physics of erosion. Thank you very much. Bye.